Do you feel the vibes?
Right, so in section 2, we're going to learn how to divide polynomials. Okay, in the first case, we are going to have a polynomial divided by a monomial, right? When you're dividing polynomials, always make sure that you can distinguish this difference. So here, if you're dividing by a monomial, you have to divide each monomial by the polynomial first. So look at this one. You have a polynomial, 1, 2, 3 terms. So multiple terms divided by one term. Always remember this first. When you're dividing, ask yourself, how many terms am I dividing by? Okay? If you have multiple terms divided by one term, you have to separate. So, the first one divided by this minus the second one divided by this plus the last one divided by this. You have to take the steps to do this. Don't do it in your mind. Write it out. Yeah.
So we have to write out.
Yeah, write it out, write it out, write it out. So now let's do each of them separately. It's like 3 different problems from last lesson, right? All in one. So in the first case, we have 5c cubed d minus 4f plus just 1, right? We're done. So it's literally 3 of the problems from last lesson in one problem. Okay? No. All right. But the thing is, remember, split, split, split. Okay. Now, dividing a polynomial with more than one term. You have 2 ways of doing it. Long division, synthetic division. Okay. Let's remember long division. Let's remind ourselves long division. Do you guys remember long division? 789 divided by 4. Okay, let's remind ourselves what long division looked like. So 789 divided by 4. So again, the final answer is not what I'm looking for right now. It's the process, right? So we said, okay, 7 divided by 4, that would be 1. Now we did 1 times 4, 4. I subtract 3. Then I bring down the 8 and the whole thing started over again. 38 divided by 4, 9. Then I multiply 9 times 4, 36. Subtract 2. Bring down the 9. 9 times 4. 29 divided by 4. 7. 7 times 4. 28. Subtract. I have a 1. Right? So that would have been the 1. Okay, so that would have been, remember, so it would have been, yeah, so 1 is the remainder. Okay. All right, so that's how we did it. So, okay, now I'm going to do long division for these. So, here we go. X squared plus 7x minus 30 divided by x minus 3. So, in here, this 789 is called, do you guys know what it's called? The dividend. You know what this 4 is called? Divisor. right? Okay, so here too, this is the dividend. And the x minus 3 is the divisor. So here we go. The dividend goes in here, x squared plus 7x minus 30. The divisor goes over here. Now, same thing. Remember how over here we did 7 divided by 4? And we got a 1? Okay, so here's what you do. The first term divided by the first term. And I like to work on my, little like scratch area here. X squared over x, I get x. And when I put the 1 over here, what did I do then? 1 times 4. So here I'm going to do x times this entire thing, x minus 3. So I'm going to get x squared minus 3x. Yes? Then when I multiplied 1 by 4, what did I do next? I subtracted. Okay, now, subtracting is the same thing as change the sign and add. Is that right? Yeah? So, changing the sign and add. So, okay, so if I do like 3 minus 4, is that the same as, right? Isn't that the same as 3 plus negative 4? Yeah, okay. So, what I like to do here is I like to change the sign and add. Oh, yeah, sorry. So change the sign and add. Okay? No, just change the sign. So another way we say it is change the sign, draw the line, combine. Change the sign, draw the line, combine. So now the x squares will go away. So I have 4x, right? And then the minus 30 will come down. No, positive. Oh, sorry, 10x. Okay, yeah, so let me do one without questions so I don't have to stop every minute, right? So 10x, okay? And then the 30 comes down. Now, the algorithm, the process starts all over again. So take a look. This first one divided by the first one. So 10x over x is 10. So plus 10. Multiply by this whole thing. 10x minus 30. Change the signs. Add. This becomes 0. This becomes 0. There's no remainder. My quotient is x plus 10. So this becomes x plus 10. Right? Yeah. Fabulous. Okay? All right. So let's do another one. Look at this one. This is x squared minus 13x plus 12 times x minus 1 to the power of negative 1. So we know to the power of negative 1. So we know this is the same as x squared minus 13x plus 12 over x minus 1. So it's one thing divided by the other thing. So let's do that. X squared minus 13x plus 12 divided by x minus 1. Okay, so here we go. Look. First divided by the first gives you x. Multiply the whole divisor by x. X squared minus x. Change the signs. I get negative 12x. Positive 12 comes down. Negative 12x over x is negative 12. Multiply negative 12x plus 12. Change the signs. Oops. I meant to do that with another color. So I get 0 again. So my quotient is x minus 12. Okay, so let's take a look at this one. So x plus 3 out here. And then 2x cubed plus 3x squared minus 4x plus 15. Now, before we start this one, let's pause. Before you actually start, there's one thing that you have to do. You have to make sure your polynomial, your dividend in here, you have to make sure that this is written in standard form. That means the exponents are written in decreasing order. And all the exponents are present. So for example, the highest exponent here is 3. You have to make sure 3, 2, 1, 0 are all there. If, let's say, you have 3, you have 2, you don't have x to the 1, you have to add a 0 in its place as a placeholder. Okay? Let's say you had x to the 3, x to the 2, but not x to the 1, you have to add a 0 in its place. Yeah. Yeah. No, just like if you had 2x cubed plus 3x squared, you would have to do plus 0 minus 15, right? Yeah. Okay, as a placeholder. Okay, so now let's do this. So this divided by this is what? 2x squared. So now we multiply, so we get what? Cubed plus 6x squared. Now let's change the signs. So how much do I get? Negative 3x squared. Negative 3x squared minus 4x. Okay, now this divided by x, we get negative 3x, right? Okay, so now we multiply, we get negative 3x squared minus 9x. Change the signs. We get 5x plus 15 plus what? What do I put up here? 5. So I get 5x plus 15. Change the signs. 0. And here we go. So my solution is 2x squared minus 3x plus 5. I know, right? That was a good one. So it could go on for steps and steps and steps. Okay, so this is definitely, we're getting into new territory now. Okay, so now we have the dividend divided by the divisor. We divide it in this way. So here we have our quotient. Now, the answer is written as the quotient plus, if there is a remainder, we haven't had it so far, but if there is a remainder, you write it as the quotient plus the remainder over the divisor. So quotient plus remainder over divisor. Now, this is long division. There is also synthetic division. Let's also talk about synthetic division. Synthetic division is a shortcut to do the same thing, but it works in some situations. So let's think about what's happening here. When we're doing this, do you see how these x's, right, are coming along for the ride? But really, we're working with the coefficients. right? The x's are just coming along for the ride. So what if we could just not keep writing the x's all the time, just write the coefficients, right? And then just like write the x's at the very end, right? So synthetic division kind of lets us do that. So in step 1, we make a chart like this, like half of a rectangle. We write the coefficients of the dividend so that the terms are in descending order. In this synthetic division, it is even more important that we don't have any missing, like we have the placeholders for all missing exponents. So remember to include 0 for missing terms. Okay? So look at this one. For the divisor, for the dividend, 3 plus 5 minus 1 plus 4. Do you see that? 3, 5, minus 1, 4. Now, this step, don't skimp on me on this step, people. You see this x minus x plus 1 here? Take this x plus 1, set it equal to 0. X equals negative 1. It is that negative 1 that goes there. Yeah? Oh, that's a surprise. No, just go with me. Go with me. Go with me. Have faith in me, people. Have faith in me.
I'll be skeptical, but I'll believe you.
Yeah. Just believe me. Now, do you?
I'm still very skeptical.
Okay, so here's what happens. Let's just work over here. So let's just work over here. The first number, 3, comes down for free. Yeah. Okay? First number comes down for free. Now, whatever makes it down to the bottom gets multiplied by that outside number, negative 1. So this gets multiplied by negative 1. What do we get? Negative 3. And here we add, just like we were adding before. So what do we get? Come on, 2. Now what happens to that 2? Negative 2. You add negative 3. You multiply. You add 7. Okay, now look. Okay, now look. This number is the remainder. Okay? Now, what did our problem start with? An x to the power of what? 3. Dividing by x to the 1 reduces the degree by 1. So, if this was x cubed, now the degree reduced to x to the power of 2. So now, count with me. X to the power of, look, x to the power of 2, x to the power of 1, x to the power of 0. So, what is my polynomial now? 3x to the power of 2 plus 2x minus 3. This is my quotient. Okay, so now let's write the answer. So the answer is 3x squared plus 2x minus 3 plus 7 over x plus 1. Okay? The negative 1 is done. That was from the divisor, the x plus 1. Because, no, because Well, you had to, because here you had to divide, right? You had to divide by x plus 3, right?
Yeah.
That's where we used it. That's where we used it, and then, you know, we got the answer here.
And then why do we have to make it equal 0?
Just to know where it comes from. But later, when we add numbers in front of it, you know, we have to know that. Okay, yeah. Yeah, I know. Okay, so, all right. Okay, so now let's do this one. Look at this. So here, look, I have 4a to the power of 4. I'm missing a 3. Is that right? So look, first I put an arrow. So I have a to the power of 4, 3, 2, 1, 0. So when I'm putting my coefficients, it's 4, 0, 2, negative 4, 12. If you forget that, your answer will be wrong. And if it's a 4-point problem, you get 3 points off. Because you literally did a different problem. You didn't even do the problem I told you. Right? Okay. So what goes here? Negative 2. Okay, so 4 comes down for free. Then minus 8. We add negative 8. What goes here? Yeah, because we added. 16. You add 18. Multiply. Negative 36. You add. Negative 40. You multiply. What do you get? 80. You add. So it was a to the 4. Now it becomes a to the 3. Okay, so you don't have to write it out all the way. Just put the first one. So it'll be 4a cubed minus 8a squared plus 18a minus 40 plus, this is the remainder, 92 over what? A plus 2. Not bad at all. Okay. Here. Okay, b to the 4, 3, we're missing the 2. So, 6, negative 8, 0. Oh, we're also missing the 1. Another 0, negative 14. You see that? And then 2 goes out here. So 6, 12, how much? 4, 8, 16, 32, and what is that, 18? Yeah? Are we sure? Plus 18. So that's the remainder. I always do that little box so I know. Okay, so now that was b to the 4. This will be b cubed. So 6b cubed plus 4, come on now, 4b squared plus 8b plus 16 plus 18 over what? Yes. I love it. Yes.
Well, you asked us to use like either.
Yes.
So we need the.
Remember on like the factoring and the completing the square and the right?
So I can't just be against the method and do it at the time.
Okay. Okay, now let's see. Let's use one problem and do it in both methods. Okay, so here we go. 8x to the 4 minus 4x blah, 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 divided by 2x plus 1. So here we're missing the 3, right? So here's what we're going to do. Yeah. So 8x to the 4 plus, I like to do 0x cubed minus 4x squared plus x plus 4. And then here I'm going to put 2x plus 1. Okay? So 8x to the 4 divided by 2x, what does that give me? Right, so here I'm going to get 8x to the 4 plus 4x cubed change the signs. So I get negative 4x cubed minus 4x squared. Right? So what do we put here? Negative 2x squared. Right. So negative 4x cubed minus 2x squared. Is that right? Change the signs. It's negative 2x squared, right? Plus x. Now we get negative x. So negative 2x squared minus x. Add the two. I'm sorry, change the signs. Oh, I got 0. So, right? Oh, no, I got 2x. Oh, my gosh. Plus 4. So what do I get? 2x divided by 2x plus 1. 2x plus 1. Change the signs. Positive 3. So I get 4x cubed minus 2x squared. Plus 3 over 2x plus 1. Now, don't go ahead of me for the next one. There is a special case here. Okay? Okay. Fabulous. That was a good one, right? This was the first one with long division that we got remainder. So you see how it works. Okay, now, what is different about this synthetic division compared to the other synthetic divisions that we've done? So many. Okay. Huh? Yeah. Yeah, so for the first time, this divisor, it has a coefficient other than 1. Okay? So, now that's a problem. So, what we have to do is, we have to divide this by 2. Okay? But, look at how this is going to pan out now. If we write this in a different way, yeah, so if I divide this by 2, or if I multiply this by a half, right? This is part of a fraction. If I multiply this by something, I have to do the same thing to the top. Is that right? In order to keep the fraction balanced. So that means if I multiply this, if I divide this by 2, I also must divide that by 2. Okay? In fact, I have to do that. I have to do that. So remember how I was saying you have to set this equal to 0? That's why I was saying that. You have to set this equal to 0. That's where you get that number, right? It's not like a blind, like, okay, -1. No, it's -1/2. Like there's a special thing you're doing. You're setting it equal to 0. You're getting that -1/2. And when you do that, and when you get that fraction, that's now a special thing that you did to it. And you have to also divide that by that number. Okay? So now, so here's what we have now. Now we have 4x to the 4 minus 2x squared plus half x plus 2 divided by x plus a half. That's what we have now. That other problem from before no longer exists for us. This is the new problem that we have now. So here we're going to put -1/2 on the outside. And we have what? 4, 0, right? -2, a half, and 2. Is that right? 4, 3, 2, 1, 0. Okay, so 4 comes down. Times negative a half is negative 2. Negative 2. Positive 1, negative 1. Right? 1 half plus 1 half is 1. Is that right? So what's 2 minus a half these days? 3 over 2. Right? Okay. Now, people, so it used to be x to the 4. Now it's 4x cubed. So I have 4x cubed minus 2x squared minus x plus 1 plus 3 over 2 over what? X plus 1 half. Okay. But this is not okay. No, 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 no. In fact, okay, why don't we just work on this? This is 3 over 2 x plus a half, like this. Is it? Let's see. This is like 3 over 2 times 1 over x plus a half. Is that better? Yeah? Because it's the first fraction times 1 over x plus a half. And then that's also 3 over 2 times x plus a half. Oh my god, oh my god, oh my god!
I get so happy.
That's so cool. Look at what happens when you distribute 3 over 2x plus 1. Yo. Oh my god. Full circle.
That was actually really
That's
cool.
like 2x plus 1 from before. Hey.
I like
Whoa.
Wait, I like
Come on.
I like
That's
both.
kind of cool.
This is
That's
rare
kind of cool.
This is rare when I actually like both ways too.
You hold it right there.
Okay, I'm holding it. I'm holding it. Okay, so 4x cubed minus 2x squared minus x plus 1 plus 3 over 2x plus 1. That is how we want our answer.
It is the same.
And look, 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 it's the same as this, man. Oh my God. Oh my God. Okay, come on, come on. Right?
The math is working today.
I mean, doesn't it every day though?
It does.
Yeah, it does. Yeah, it does. That's so crazy. This is why we like math. Right? Come on. Come on. Geometry was never this cool.
Geometry
No.
definitely is like
No.
That's true.
No, yeah.